recording right now. You see it? Yeah, just hold it. Here's the button. Just hold it right here. Yeah, you got it? Got it. Just keep it on there. I'm going to shut it off.
Freaking great. A little drag bike. Okay, you can shut it off now.
Where? Button?
Yeah.
Wow, look how clean it's got there.
Now, traditionally, I don't want to ruin your fun, but traditionally the first OMAX part, Maxium part, is hung on the wall in the office.
Oh, is it? Well, you guys cut some the other day.
You want to put that block up there?
There it is. It's going to be hung up on that wall.
Hey, now seriously, before you...
Yeah, put a hole in, you need to put a hole.
Awesome.
The OMAX and Telemax software consists of OMAX Layout, a CAD/CAM system for designing parts and making them into tool paths, OMAX Make, machine tool control software for positioning the machine and running tool paths to cut parts, and help screens and other miscellaneous utilities. We'll go quickly here. The purpose is not to teach you how to use the software, but instead to simply demonstrate the complete process and the steps involved. We'll start in OMAX Layout. And what I'm going to do here is draw a simple box with a hole in it. So I'll start with the box command. I'll just click somewhere on the screen here and we'll make this a 3-inch wide box by 2 inches tall. And now I will draw a circle in the center of it. I'll make a circle and we'll go from the center of this box and we'll make it a 1-inch diameter circle. And there's the geometry of the part that we're going to cut. Then the next thing I need to do is actually assign cutting qualities to these various drawing entities. What a cutting quality allows you to do is it allows you to say, hey, I want this particular feature right here to be cut really quickly. I'm just going to weld against this and I don't want to waste the machining time trying to make a nice smooth finish, so we'll set it to a quality of 1. And then maybe the center hole here, we want it to be a higher tolerance because we want to fit a bolt through it. So this will cause it to cut a little bit slower in this area, but the end result will be a smoother, higher tolerance surface finish. Then on the remaining pieces, I might make them quality of 2 because they just need to be cosmetically nice looking, don't have to be high tolerance, but we don't want to waste a lot of time on those. So you can optimize your tool path by choosing which areas for the machine to spend a lot of time on. So the next thing I need to do is I need to tell the machine the sequence in which I want to do things. And a simple tool for doing this is the AutoPath command. So now I'm going to save this. And I'm just going to save that as box with hole. And now that's saved. The next step is to take this DXF file and turn it into an actual toolpath file. And that's done with this path command here. I can preview it here with some arrows to see the direction things are going and so forth. And if everything is to my liking, I can save this. So I'll save that, and now we're ready to use Omax Make to actually cut this part. This is Omax Make, and its purpose is to position the machine, and it's also, of course, to run tool paths and cut parts out. So the first thing I'm going to do here is click on the Change Path Setup button so that we can choose the tool path that we created earlier in Omax Layout. Now the primary things that I need to do at this point is that I need to tell Make what material we're going to cut it out of and what thickness. So I'm going to tell it here that we're going to make this out of aluminum, and we're going to make it out of 3/16 inch aluminum, and I'll click OK. And now what it does is it quickly calculates the tool path. And when it does that, it applies a cutting model so that it can optimize the speed versus precision as specified by the cutting qualities earlier in layout. At this point, you can see that the estimated time to make this part is going to be a little under half a minute, and it's going to cost approximately 19 cents to make this part. I can preview this part to the screen, and it'll show me in various colors the different speeds that it's going to go. The next thing I need to do is I need to position the machine. So I'll go ahead and I'll move the machine. The next thing I'll do is I'll click on Begin Machining, and we'll click on the Start button. Now the machine is cutting. You can follow along on the screen over here what the machine is actually doing. And you can see over here the time remaining, 16 seconds, and the progress. You'll notice that this path controller here is much like a VCR, meaning you can pause it, you can go back up, you can fast forward, and so forth. At this point, the machining is finished. I can close out this dialog, and I can remove the part. Here's a typical part in 1-inch thick aluminum. What I'm going to show you is how we can make this part much faster through software optimizations. I'm going to hit preview to screen here, and you can see that this part is going to go fast along some of these straightaways, but it has to slow down in order to make these corners precise. Software can speed this stuff up. I'm going to click on Setup, Cutting Model Optimizations, and I'm going to turn on some of the Omax exclusive cutting model optimizations, ranging from IntelliPierce, which optimizes the piercing, and IntelliCorner, which optimizes the inside and outside corners to be faster. You'll notice here that it has grown the lead ends to be an optimal length for the piercing, and it has also added corner passing onto the corners to speed those up, and it has also done some invisible optimizations throughout the various corners as well. Now you'll notice it's the same part, same thickness, same material, but instead of being 11.2 minutes, it is now 7.7 minutes. A very significant savings in both time, money, and consumables.